Right. Good afternoon, everybody. Good, this is working. This is Dylan J, the CTO of Pre2Web, a CMS cloud provider instrumental in the adoption of Plone as a government shared web platform. He's an open source developer releasing Plone projects such as FunnelWeb and HostOut. He's also the current convener of the Sydney Python Users Group. Please make him welcome.
Thank you. So I hope you all share the pain. I've spent the last couple of days doing too much JavaScript because this is mostly JavaScript. So let me go back to the presentation. Okay, so this is about Pythonic real-time web and a little bit of Node.js bashing. So my company, we mostly do government, we do CMSs, blah, 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 blah. There's the demo, you saw it before. Now, a couple of tips with the demo. It uses your orientation sensors. If you've got a MacBook, try moving it left, right, forward, back. Don't use it on Mozilla Firefox, it doesn't seem to work. I'm not 100% sure why, I was too busy playing around with the orientation stuff. So, real-time web is more or less about that kind of thing. It's about getting instant updates, and that's why I kind of yesterday re-implemented it. I had this GPS kind of thing, and you could see everyone's location. I realized that everyone's going to be here, and their location's not going to move, and it's going to be really, really dull. That's why I put the little orientation thing in there. And I didn't want to do a chat app, because everyone does a chat app. So Node.js, who's heard of Node.js? Right, see? The hype is kind of working well. So it's a JavaScript server-side kind of networking, a little bit of a frameworky kind of thing. And it is kind of up on that hype cycle, you know, where, say, Rails is maybe kind of plateauing, going down, and Python is this kind of sleeper that's just kind of gradually going to take over the world. So Node's goal, they kind of want to make doing this networking stuff really easy, and they've kind of say, there's a lot of stuff about how super efficient and fast it is, as if it's this brand new kind of thing. This is a really good article to read about some of those claims. It's, I'm not going to go too much into it, but I mean, basically what he's saying is that, okay, yeah, you know, because it's using asynchronous IO and various different things, yes, it'll kind of run fast, but then if you want to build scalable apps, it's a lot more about just having one little part of the thing work well. You know, you've got to understand exactly what's going on, and there's charting, all sorts of other things that come into play when you really want to make something scalable. So it doesn't solve those problems. It's not a magic kind of thing. And getting the idea that you'll get a whole bunch of really good programmers because everyone knows JavaScript isn't necessarily going to work either. So the Python way is just as simple, in my opinion. The pros of doing this kind of thing in Python is there's lots of options. But the cons are there's lots of options. So what I want to do is kind of run through, you know, when I started playing around with this, there's so many terms, and it's kind of confusing. So what I really want to do is, instead of, I could just show you the code and say, do it this way, I wanted to kind of talk about what some of the terms mean, try and get you to sort of get your head around it so it's easy to understand when you see a lot of these terms. So real-time web is basically the idea of having like a socket, some bidirectional connection between your web browser and something on the back end. So you're not doing polling. Well, that's a lie, but so how you do that, there's this new protocol, kind of a little bit like HTTP, but it's called Websockets. It kind of has header information, but you end up with this bidirectional socket that all your proxies and everything in between are going to understand. It's going to stay permanently connected between your browser and the server end. But it's largely unsupported, and there's a couple of different implementations of it to kind of make it harder. But things like Chrome and Firefox will support it. I think IE9, I'm not sure. So at this point, you're going, well, that's great. You know, I've got this brand new thing that it would be awesome to have all this, you know, real-time updates into my browser, but I can't use it because it's not supported. Well, there's a couple of cool libraries that can help you get around that. So Socket.io is the older one. I'll talk about it in a minute. So I only found out about SockJS this week, and so I re-implemented it because I was having a few problems with Socket IO, and it's now in SockJS. I like it a bit better, but the basic idea here is that it uses this kind of back-off. It will, for all the different browsers, pick something that gets you as real-time as possible. So you'll notice that polling's at the end. So at the very least, it'll do something that'll send a request, get something back, and kind of, to all intents and purposes at the client server end, act as if it's a single bidirectional kind of socket. But then there's some clever stuff in between where it'll like do a long poll. It'll send a request and keep sending stuff in the header, and then it'll have a second one, and it'll keep sending stuff back, and it'll create sort of 2 requests and try doing things that way. The basic idea is you don't really need to worry about that. It's handling it all in the background. So it looks a little bit like that. I might show that in here instead. So you can see here that you've created a connection. We've got this little SockJS thing. So one of the nice things about SockJS, as opposed to Socket IO, is SockJS pretty much follows WebSockets API. So you can use it like it's a WebSocket. SockJS said, we can improve on this, and they added all this extra kind of, in my opinion, crap on top, which has problems like it will automatically do JSON serialization at each end, which is great unless you really, really, really want to make things very efficient and don't want to JSON serialize your data. They've improved that, they've changed that a little bit. So then you have, you define a couple of functions. You're on open, you're on message, and you're on close. So for this app, what we're doing is on open, we send our current location. Every time we get a message, we show that pin or update that pin, and then we'll clear the pins when we close. That's in case we reconnect, and then we'll try reconnecting. That's all there is to it from the client side. So, yeah, Socket IO is a bit older. Yeah, pretty much everything I talk does a whole bunch of extra stuff, has some protocols which are a little bit troublesome. So there's other ways. There's comment, which is basically doing stuff in the background that these other things make transparent. I don't recommend it. Sockets is, don't discount sockets. If you're not actually running in a browser, just use a socket. Like for instance, if you're doing sort of Android development or something like that. So server stuff. That's the current implementation of the SockJS. So the one I'm going to be using is the Pyramid SockJS, but you've got lots of options there. So the server side. So I want to talk about asynchronous IO and what it means. And to understand asynchronous IO, you're going to understand threads. So threads is a way of doing multiple things at once. They're kind of simple to understand. You start a thread, then you keep going as you did before. You loop around, eventually your thread ends. The only thing you need to understand about is locking and making sure you don't write to the same thing at the right time. So what's wrong with threads? Well, here's an example of a threaded server. So yeah, this is the simple one. Sorry. So the thread server. So here's an example of a threaded server. What it does is it takes, it accepts a TCP connection. Whatever you type, it does a connection in the background, turns it into pirate speak, and sends it back to you. So this is where they kind of talk about efficiency and scalability and blah, 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 blah. What they're really saying is that, okay, if you really wanted to accept lots and lots and lots of connections, you do have a slight problem with threads, no matter, not just in Python, but every time, because the language is actually doing the context switching between the different threads, and in order to do that, it needs to kind of save the stack and put the stack back and stuff. So you get this overhead of switching. And essentially, asynchronous IO is a reaction to that, which says, well, we know better, we can do that in our application itself and don't have this cost of swapping midstream. And this is a graph that kind of shows that. So you start increasing the concurrent workers, with something like gevent or twisted, and you get less overhead. You can basically handle. This is a measure of overhead, so you can read that and how they worked that out. And there's a very famous kind of paper blog post all about the 10K problem, which is how on earth do you handle 10,000 connections on a single machine? And you can't with threads. You need something like this. So, asynchronous IO, you're running in a single thread. The language, your application is deciding what to go next. So it's not preemptive. You don't have this switching context midstream. But there's a big caveat here. You can't block. So if you do something that writes to disk, or just a timer event, a little sleep or something like that, everything else is going to get starved. You need some way of doing cooperation between the different parts of your code. And so anything that does I/O, like you receive stuff, you want to write stuff, you want to do a database call, anything like that, that's the point where you need to hand stuff back over to the library, gevent or twisted or whatever, to let something else have a go. This means that you need new I/O libraries. You need a special database adapter or a special file system call. And this is where it all gets a little bit messy. Node.js doesn't kind of have this problem because they don't have threads, and they never did really. So they can, and they've built everything from scratch because there wasn't really much server-side JavaScript. So they don't have a whole standard library worth of stuff like we do in Python. So yeah, JavaScript, you've got Node.js. There may be others, but I don't know what they are. So we've got lots and lots of choices. I've bolded the ones that you're probably going to deal with or have heard about. So one of the interesting things is how callbacks work. It's kind of a style thing. So if we have a look at, say, that the same one that I was talking about before. So this is roughly what Node would do, right? So it's doing the same pirate thing. And the really important bit here is you can see where it says get. It's doing a get, and then it's passing in a function, which is what you do at the point after you've got it. So it's using callbacks, what they call boomerang code. And this is how a lot of these things have to work. You have to say, I'm going to hand it back, but I'm going to give you something to do when you actually get the data. And then you also, on top of that, have to tell it what to do if you get an error, because you can't just use try and accept anymore. It's not, the flow is kind of gone out of your application. You're doing things in a different way. If you're used to JavaScript, you kind of know that you have to do this stuff in the browser anyway, because it's also single-threaded. But it's a very different way of working for Python people. So if we have a look at the same thing in, say, twisted. Okay, so here's a twisted way of doing it. You can see what we've got here is we've got the callback, and then we add the callback to this get page. And I think that's right, it kind of magically puts it together. The problem with this is it's kind of a little bit counterintuitive. You're writing your code before what you want to do, and then you add it, and then you execute it. And part of that is because we don't have proper closures in Python, we can't just sort of magically put the code afterwards by embedding the function in the call itself. So, if you did that, you'd at least have it afterwards so you could read it going down. There is a kind of inline way of doing it with twisted. It's not really recommended, and it kind of does your head in more. They use kind of weird yield statements. So that does the same thing. So enter gevent. This is part of the reason I like gevent, is that you don't have any of these problems. Oh, crap. Okay, so gevent. This is where it really gets a minefield in terms of terms, right? So you got these things called coroutines. Coroutines is the idea that you're implementing multitasking as if it was threaded, for instance, but without actually having threads. So you're allowing the application to switch between different contexts. So you have these things called greenlets or eventlets, which act like threads. They kind of have a thread API, you use them like threads, but they're not actually threads, it's doing something tricky in the background. You have an event loop, kind of talked about before. You have some of these things called libevent, or these are things that the framework has to use to cooperate with the operating system to get the events of when I/O is coming in. Then you may also come across something like gunicorn, and that actually lets you do synchronous threaded stuff, and it lets you do asynchronous stuff, and it's a nice kind of it handles multiple processes and stuff. It's kind of container, whiskey container for doing a lot of this stuff. Monkey patching is something that comes into gevent. So let's just have a quick look at how this monkey patching works. So here is the gevent one. It looks a lot like the threaded example. This is the nice thing, is that you just do it, and you do a URL fetch, and then you do the next thing, and then you do the next thing, one line after another. You don't have to change your way of thinking that much from threads. But gevent's a very low-level thing. It doesn't go and give you all these new nice functions to use. So you actually see in this example, I've had to go and override and do a special gevent URL fetch thing, to make that magic happen. But gevent has this really, really cool feature where they'll just, because they've got all these APIs that are pretty much like threads, sockets, URL, lib, etc., they do use this gevent monkey patch, and it will monkey patch most of your standard library, doing everything asynchronous background. So all your sockets are now become gevent sockets. All your threads become gevent threads. So then I can write this exactly as I would have done as a threaded thing, and it will work asynchronously. It doesn't completely stop you not having to understand what's going on. You still don't block in the middle of a thread because, or depending how you block, you still have to be a little bit careful. For instance, I was playing around with funcload. I wanted some better performance out of it, and so I did the monkey patch all on it, and it worked, but it gave me different funcload load testing results, which was kind of interesting. I'd like to know why. Okay. So Tornado, I did try it. It's kind of its own little world. It's kind of a framework and a server in one. So Whiskey's kind of a second-class citizen there. It's sort of off to the side. It doesn't kind of it does support it. You can put your Whiskey app and your pyramid or whatever it is in there. One of the things I just didn't work for me, and they may have fixed it, is that I couldn't run my socket IO or my WebSockets on the same port as I was serving the HTML from. So I couldn't, which kind of ruined the niceness of the application for me. Okay, so how did I build this particular app? I was using Pyramid. Kind of like Pyramid. It's kind of like a micro framework in that you can build it on one page, but it's got a bunch of stuff that kind of makes things explicit, that's kind of built to help you really grow your application, so you can override things later. It's not going to kind of be a dead end where you really want to build something that's reusable. It will help you along the way. I used Pyramid SockJS, and I used Google Maps and a whole bunch of other stuff in the JavaScript thing. So let's have a look at that. So right at the bottom, we can do a little in-place server, start a server straight away. We've got a little Whiskey thing here, which creates the Whiskey app here. We've got Pyramid has this configuration stuff, so I've defined where my JavaScript is going to come from, and you've got the special thing that comes out of this include Pyramid SockJS, and that adds a SockJS root, and I map the session to a class. So this is going to build me a class every time a SockJS connection is made. So if we come up here, it was really simple before, and then I started adding bits and pieces. And so here's my model. Here's my data model. I've got people, and it's a set. That's it. Anyone looking at this will realize there's a big problem here. I don't actually have any sort of distributed model that sits in memory. I can only run this on one thread, otherwise I will have different sets of people depending on which process you connect to. Pretty easy to solve with something like Redis or something like that. So my map session gets created. Then I get an on-open event. So I set a little UID so that when I send it moves out, we know who's who. I add it to my data model there. And then I send all the locations of everyone I currently know about. Send all, goes through all the people, sends out, and does this. So this little JSON dump thing you don't have to do with socket.io. But for WebSockets and SockJS you do. And we got this on message here. So I extract out the latitude, longitude, and the direction out of the request coming through. I put that as the last location, so I can do that send all, and then I broadcast it to everybody. And that's it. That's pretty simple. So, was there anything I else had to talk about? That's it. Any questions?
Thanks very much. Can we have a round of applause? It's getting late in the day. Was there any questions that people had? Want to ask?
A more general comment or question about asynchronous programming. One criticism is that because it's single-threaded, it cannot typically by default make use of multi-core CPUs.
Mm-hmm.
Can you speak to workarounds for that problem?
Well, essentially, you've got to design your application to have some kind of, like, I probably should have increased that one and made it work on multiple cores. So you could use something like Redis or memcached or some kind of central store in the background that then sends connections between your different worker threads. So Redis has this nice pub-sub kind of thing where you can, essentially set up a same sort of listener thing, and so I could send a message to that, and then it would broadcast it to all my other workers. Then they would send it out to all the different WebSocket connections, say. That's essentially how you'd solve it.
Okay. Or, have you used Python's built-in queue module as well? Okay.
Yep.
In process. Okay.
So anything that would queue it and let it go to all the different processes on the same machine or multiple machines is kind of what you want. You want to publish and have a whole bunch of subscribers. They all get it, and then they send it back out at the other end to all the clients.
Anybody else? Oh, there we go.
So I was a bit confused about because JavaScript makes you do asynchronous programming on the client, why that force you to do asynchronous programming on the server?
It doesn't force you to do it. Nothing forces you to do it. There's probably threads in JavaScript on the server now. I'm not sure, but I think. Sorry.
In Python on the server.
Also, why do it in synchronous? Well, you don't. That's the thing. I mean, if you go back and look at that graph, right, one of the really interesting things is for small amounts of connections, threads is actually more efficient than, say, gevent. And this is one of the kind of fallacies, is right. You don't have to use asynchronous on the server. You can use threads. It is just about, and it's only a problem you have when you want 10,000 connections. So there's no reason to do asynchronous on the server. Okay. But, you might as well.
Because it's fun.
Because it's fun.
Have you had any experience mixing the two together, like asynchronous and synchronous? Like if you've got a web app that's mostly, you want to do it threaded.
Yeah.
but then you're going to have some kind of listening thing or something that does the asynchronous, so you can get notifications and stuff. Do these things talk nicely to each other? Like, can you just import a Django ORM and then access your data and stuff?
Yeah, I mean, one thing I forgot to tell you is the gunicorn stuff. So this bit here is actually like a paster thing. This is how I run this when I deployed it to the server. I actually used gunicorn instead of that thing. And so I've got a little worker there, which is the egg gunicorn main. And one of the really nice things about gunicorn is you can have sets of different kinds of workers. So you can have synchronous workers, and they, then you don't have to change your application or worry the I/O about in the background. They do all the synchronous stuff, and then you have asynchronous workers. So you can kind of mix and match, which is quite nice. The other option is that this app was serving all the HTML and JavaScript and everything using an old whiskey pyramid without, because I wasn't doing any database connections, I didn't really have to worry about that, and it was all doing it via gevent, and nothing needed to change. So you can just, serve, as long as you're careful about how your application is built, you can actually get some efficiencies and run things in gevent or twisted without changing it too much.
Any other questions?
Do you know if gevent does asynchronous file system operations as well, or is it only network stuff?
Yeah, I believe the latest version, I think, has, what do they add? There's various plugins for gevent rather than just the core as well. And one of the things they added in the last version was sub-process support. And I think there was talk of like file writes and stuff. So I guess it's not a problem. It depends. You've got to do a really big file write, I suppose, if you want to take advantage of that. So I think it's kind of underway. I don't think it's in the current 1.0 version.
Anybody else? Okay. Cool. Thanks very much.
Thank you.
Some